I don't. It displays it how it wants over here, so we won't worry about that, right? It's rearranged it, and right now it's a 1 here. It shows it as, whoops, that's not good. It shows it in a different form. It shows it, if you can see this here, it leaves this always equal to 1. And again, it's very unfortunate you haven't done conics in Math 12 because you'd know all this otherwise. If you want to see what's happening here, the reason they write it like that is they do this. They take this thing and they move the x squared to the other side, so it says y squared minus x squared equals this constant of ours. But then instead they just divide everything by that constant. The standard form for that type of relation is y squared over something minus x squared over something equals 1. Now in this case, this happens to be the same number, right? That's C2 there. That's why it's displaying it like that. This is called a hyperbola. That shape. The equation looks almost like the equation of a circle. If this was a circle, this would be a plus here. If that was a plus, it would be a circle, right? If we go back to this and change it to a plus, it'll become a circle. This gives you all the different curves here that are possible. Okay, now actually, I'm wondering why.
What does it do with 0?
Yeah, it seems to not.
It doesn't like 0.
It doesn't like 0?
Oh.
No, I got to tell you what this is. This is a this is a hyperbola. It can either open up when that constant is positive, or it's going to open sideways. Opens up and down, or opens sideways here, depending on whether the constant is positive or negative. You notice how it simplifies it over here. When the constant's negative, it doesn't seem to make this negative. It just switches the terms around, right? So when it's y squared minus x squared, it opens up and down. When it's x squared minus y squared, it opens sideways. When it's right in the middle here, it is what you call a degenerate hyperbola, because it's just two crossed lines. Oh wow. It is. This is a degenerate hyperbola. Well, if you multiply this out, you'd get, like if you go back to here and look at why it's a degenerate hyperbola. If this constant is 0, you get y squared plus x squared. Actually, you get y squared minus x squared is 0. So you have x squared is y squared. So you have y is plus or minus x. So it's just those two lines, plus x minus x.
So you get x squared over c, which is...
No, because this is in the single case where that c is 0. It degenerates to two crossed lines when c is 0. Next, degenerates. I think you probably have worked with circles before, right? I won't let me do this. You have never worked with circles before? Well, if you were to change that to a plus, you'll see it's a circle. Let's not worry about that right now. All of these possible curves are possible solutions. It isn't just a vertical shift, right? The first couple things we looked at, the C value represented a vertical shift. It's important to realize that in this case, it doesn't represent a vertical shift. It represents something else. It's not always going to be a vertical shift. This represents the shape of that hyperbola. Okay, depending on what you're starting with. The fact that this one had x and y involved, the C value doesn't just represent a vertical shift. If it's just a function of x here, that's what the C value is going to represent. All right. There's some more there for you to try. And then this is a key question here for you to think about, what the solution would be if you were given a point there. Okay? Can you try thinking about that right now and solving these two? I will pause this. Now that here it is. After all that, sorry I didn't record that, but there it is. If you have at this point, if you have e to the power of that plus that, you need to think about your exponent laws. If you have e to the power of a plus b, you could write it as e to the power of a, not plus, not minus, times. Try anything.
Would if it was minus, would it be
So,
divided by?
so you could write it, yeah. So you could write it like this, right? That x squared times e to the power of c. E to the power of c is still just a constant, right? It's not 1, because c can be any value. This is a constant. So probably in the answer key, it might just use some other constant. It might, you could call this constant number 1 here, right? And then just use c as the constant you get.
It says plus C.
We're going to have to thoroughly go through that whole answer key, judging by the first bit of it here, okay?
Uh-oh.
The only thing worse than no answer key is a wrong answer key.
Maybe we should just...
Y equals, just stay with me here, y equals e to the 1/2 x squared. This is times whatever. You could call e to the power of some constant. You could call it something else, k. You could call that c1, and this could be c2. Normally, for an exponential function, you write the constant first. Like if it's 7 times e to the power of something, you write 7. So you could put that constant in the front. That's just personal preference, though, I suppose. Okay? This can be some other constant. It doesn't matter. Just because eventually when we start working with exponential functions, you're going to write them in that form like that. I guess I should stick with what I'm calling it here. I'm calling c equal to e to the power of c1. If that makes you unhappy, then too bad for you. This one we can leave right now, can't we? Okay. 1 over root y times dy equals x squared dx. Or in other words, this is y to the power of -1/2, right? dy equals x squared dx. Just use the power rule on both sides. When you integrate, if you integrate this and you integrate this, y to the -1/2, what does that become? Y to the 1/2, and divided by this new thing, so it's times 2, right? And we got 1/3 x cubed plus a constant here. If you want to isolate that, I guess, if you want to isolate the y, you can divide everything by 2 if you really want to. 1/6 x cubed. Again, I'm just going to call that constant number 1, and I'm going to change it because it's dumb to put constant divided by 2 because it's still any possible number, right? And y to the 1/2 here, square root of that. I mean, you can write square root of that if you want. You can square both sides. Squaring both sides, you're going to get actually then 2/2 of something. If you write y equals that squared, which you could, you'd have to graph both of them and see, because I don't know if this is going to... Probably.
That is correct. It is x to the 6.
That's what confused me.
No, because if you multiplied the whole thing out, I would just leave it like this. Personally, I would leave it like this. I wouldn't bother expanding it. What?
It has a square.
It has a squared and it has x to the 6 in there? Okay, we'll have to, again, go through that thoroughly, that answer key. Okay, but before we lose sight of the actual important point here, and maybe it's so important we should stop and start again.